my dear students. Welcome to IMS Gate Academy. I hope you are doing good with your gate preparation. And remember, my dear students, as we are inching towards the gate exam, I will tell you 3 important mantra to crack the gate exam with a simple logic. Let me tell you the first thing. For every subject, my dear students, make the formula sheet. Second important point I would like to tell you here is, please make short notes for every subject. Okay? For every subject, my dear students, you have to maintain the short notes. And the third important point is, whenever you are solving the previous year gate question, you have to write the key pointers in a separate notes. So with these 3 points, definitely you will have high chances to get a better rank in the gate exam. And remember, my dear students, once again, welcome to IMS Gate Academy. Myself, Sandeep Adari, lead mentor at IMS Gate Academy. I have trained almost 10,000 students across the country with an experience of 10 years. Now, my dear students, let me tell you the important facts about the IMS Gate Academy. Students, are you looking for a perfect gate questions? Are you looking for any updates on the YouTube channel? Or are you looking for the best practice questions every day? Or do you want to test yourself every day? Then here at IMS Gate Academy, with the name IMS Gate 2425, we have created a huge Telegram group link where you can click the link which is mentioned in the description. Just join the link and you will get all the important updates. Now let me tell you why IMS Gate Academy has been rated high. My dear students, key success for IMS Gate Academy is the student success is the best solution for any academy, and we follow the same thing. And remember, my dear students, we at IMS Gate Academy provide one-to-one mentorship where we understand the student's weakness and strength and how the weakness can be converted into strength. And my dear students, we have an excellent option called doubt solving portal, where any doubt mentioned in the doubt solving portal will be solved within 24 hours of time. And if he requires still a video solution, if in case, video solution will also be provided. And we at IMS Gate Academy proudly say that we are offering the offline gate coaching at Jayanagar, Bangalore, and also at IMS Vijayawada near Bench Circle. And as part of the civil engineering, as part of the different branches, we are providing 800 plus hours of gate online and offline gate coaching. For every practice, suppose if Virat has to be best in his cover drive, he requires a lot of practice. Similarly, in gate exam, my dear students, we are giving the excellent question booklets, subject-wise material, exercise book where it contains level 1, level 2, level 3 questions. Here you can understand the variety of the gate questions, which includes MCQs, multiple select question. And remember, my dear students, if you have to score a best rank in gate exam, your concept should be very good. So, my dear students, good evening, Nikhil. Sir, please go below open tab. Okay, fine. Thank you. Thank you, Nikhil. So here, what I would like to tell you, important thing is, students, when I talk about the mentorship, when I talk about the subject material, when I talk about the exercise book, all these things are done by... Okay, now it is visible, right? Okay, thank you, Nikhil. Now see, students, with this, I would like to tell you the most important thing is, if you want to have a best practice for gate exam, then definitely you have to see our material, because in the gate question booklet, we have given the video solutions. In addition to that, we are also providing the key pointers which are done by the excellent faculties from NITs and IITs. Now, my dear students, I don't want to waste your time in this aspect, and we will quickly go into the subject. Now, my dear students, why do you want to study about the subject hydrology and irrigation? In a country like India, where agriculture is the important factor, so water is an important source. So how this water can be diverted from the rivers and how this water can be efficiently utilized, these are the things which you will be studying in hydrology and irrigation. So it's a very important subject, my dear students. Through GATE exam also, let me tell you, my dear students, there is a one specialized institute for hydrology and irrigation, which we call it as NIH, National Institute of Hydrology. If you are from Andhra Pradesh, you can apply for internship also in National Institute of Hydrology, which is located in Kakinada. And it was also located in Uttarakhand also. So I'm not going in detail of that. Just for your information, I'm giving this. Now let us solve the most interesting question. Now, my dear students, a catchment may be idealized as a circle of radius 30 kilometers. There are 5 rain gauge stations at center of the catchment and 4 on the boundary. The annual rainfall recorded at these stations are given. Using the Thiessen polygon method, what is the average rainfall? So, my dear students, whenever these questions are asked, let me tell you how do you calculate the average precipitation. So, my dear students, how do we calculate average precipitation is given by the formula sigma I is equal to 1 to n pi into ai upon sigma I is equal to 1 to n ai. So this is the formula how we will solve the average precipitation related to the Thiessen polygon method. Now let me tell you how do you understand this problem. There are 5 rain gauge stations, 1 gauge station at center and other rain gauge stations at the periphery of the circle. Now let me tell you how we will solve this problem. So here see students, if I draw the circle here, one second students. Okay, here see students, just a second student. Now here what I would like to tell you here is, we have a circle here, okay, which is of red, okay. Here we have a station, see students, here we have a station at here, and here we have a station, and here also we have a station, and here also we have a station, and one station at the center. Now my dear students, let me tell you, whenever you have stations here, just join the stations with a straight line such that a triangle is formed. You have to ensure that you have to join all the rain gauge stations such that a triangle is formed. So here see students, if I draw the perpendicular bisectors to these lines. Now see students, we have a perpendicular bisector here. We have another perpendicular bisector here. We have another perpendicular bisector. Now try to join these lines. Now try to join these lines, students. Okay. Now see students, here whenever they have given you like this, they have given circle radius is how much, students? Can anyone tell me? They have given the circle radius as 0. They have given circle radius as how much, sir? 30 kilometer square. Sorry, 30 kilometer. They have given the circle radius as 30 kilometer. Now, my dear students, let me tell you the important thing, Amma. How do you calculate the area of the circle? So, if I see here, if I calculate the area of the circle is nothing but pi r square, which is taken as pi into 30 square. Okay, now see students, if you take this one as G1, if they have given the naming convention G2, G3, G4, G5. Okay. Now what is this area? If I take this as radius is how much, sir? 30. So this will be 15 and this will be also 15. So it is a square of radius 30. So if I take the A1 area, A1 is nothing but a square of side 30. So 30 into 30, 900 kilometer square. And remember, sir, this is the area of entire circle. Now let me tell you, here we have one part, this is part 1. Suppose if I have taken this as one area, and you can take this as another area 2, and you can take this area as 3, and you can take this area as 4. Now, how to find out the area of individually? How to find out the area of individually? Very good, very good, very good, Roy. Now, how do you calculate the area individually? Area is taken as area of the circle, that is pi r square, that is pi into 30 square, minus the area of square divided by 4. Sir, when I am drawing this diagram, I lost the values. Let me check the values. Okay. Sir, see. So here if you calculate the area, you will get the area as 481.86 kilometers square. Okay. Now see students, you know the areas individually. You have calculated the areas of A1, A2, A3 and A4. Okay. And we have calculated the area also. Now what we have to do is, I told you right, we have average precipitation is equal to, sigma I is equal to 1 to n pi ai upon sigma ai. Okay, my dear students, is this clear, sir? So when I write this, we have the individual precipitations. If you solve this problem with the values, you will get a value of 91.256 mm. So this is the final answer, sir. Sir, when I am drawing the diagram, circle, I have lost the values. Okay, that is the reason. Now we are moving to the second question. What is the second question? The second question is also similar to this, sir. What we have observed here is, see students, we have station G1 here, we have another station G2 here, we have station G3 here, and we have station G4 here. So see students, we have 4 stations here. Are you able to understand? Now see students, first we will have a perpendicular bisector here, we will have a perpendicular bisector here, and we have a perpendicular bisector here. So the first point, you got point here, you got a point here, you got a point here, and you got a point here. Now what you have to do is, you just join this such that a triangles are formed. 1, 2, 3 and 4, and this is 5. So the formula is same, students, here. How do you calculate the average precipitation, sir? If I talk about the average precipitation here, the same formula for Thiessen polygon method. The average precipitation is given by the formula sigma I is equal to 1 to n pi ai upon sigma I is equal to 1 to n ai. So this is the formula for average precipitation. Am I clear, sir? This is the formula for average precipitation. Now how to calculate A1? Now see students, how to calculate A1 is the total distance. The distance from here to here is how much, sir? 25 by 2. Here to here also 25 by 2. So my dear students, if I talk about A1, A1 is equal to A2 is equal to A3 is equal to A4. All these areas are same. We have 4 areas. What is the area of triangle, sir? The area of triangle is nothing but half into base into height. So half into base into height. What is the area you have? Half into base is 25 by 2 divided by 25 by 2. So my dear students, if I do the problem here, 625 divided by 8. What is the value of 625 divided by 8? So if you see, what is the value you will get, sir? You will get around 78.125. How much value you will get, sir? You will get a value of 78.125. So what is the units here? What is the unit, sir? It is in kilometer square. So this will be 78.125 kilometer square. So my dear students, here we got A1, A2, A3 and A4 as how much, sir? 78.125 kilometer square. Now, how do you calculate A5? Sir, see, when I talk about area of 5, okay, it is a rhombus. Yes or no, students? So this diagonal, if I see, this is 25, and if I see this diagonal, this is also 25. Agree or not, my dear students? So here, what will be the area of 5 is half into 25 into 25. Area of rhombus is nothing but half d1 d2. So it is 625 divided by 12, which value will be equal to 312.5 kilometer square. Now, my dear students, you know what is the area of A1? It is nothing but 78.125 kilometer square. Now, let us see the values here. G1, G2, G3, G4, G5. G1 is 300, 285, 272. So, G1 is how much, sir? 300 into 78.125 plus 285 into 78.125. This is A. I'll show you this is what, sir? G1. This is A1. This is G2. This is A2. Plus G3 is 272 into 78.125. 272 and 290 and 288 plus 290 into 78.125 plus 288, right? What is the value, sir? 288. 288 into 312.5 divided by, what is the total area, sir? What is the total area? We have 4 areas of same. We have the 4 areas. So 4 into 78.125 plus, what is the answer we have? Area of 5 is 312.5 kilometers. Now, my dear students, what is the answer you will get? If you solve this, what is the answer you will get, sir? You will get 287.375 mm. This is the average precipitation. So, my dear students, let me tell you one important thing, Amma. Whenever you are talking about Thiessen polygon method, it was also asked in the GATE question, GATE 2023. So that is the reason I am telling you. I'll tell you some key points here, sir. Whenever you are following a Thiessen polygon method, let me tell you one important thing, Amma. Whenever you are following Thiessen polygon method is, you have average precipitation is equal to sigma I is equal to 1 to n pi ai upon sigma ai, I is equal to 1 to n. This is the formula for Thiessen polygon method. But what I would like to tell you is, suppose if it is a circle, we have stations here, 1 station, 2 station, 3 station, and a station at a center. Now, my dear students, my suggestion is first join all the stations with a straight line. Now, drop the perpendicular to these lines, and you will have a centers that. Now, join these lines such that a triangles are formed. So, this is one area, this is the another area. If you see, this is one area, this is another area, and here you have the another area. So, this is how. So, what is the final point I would like to tell you is, join all the stations, drop a perpendicular, and find out the areas. I hope this solution is clear for you. Now, please solve this question. I'll give you 2 minutes of time. Please solve this question. Students, please try to solve the problem, Amma. Okay, sir, I have given you enough time, Amma. Now, see, students, what he is asking is, see, students, in a catchment, there are 4 rain gauge stations. So, whenever there are rain gauge stations, students, whichever, if you see, you can take the missing station. But here, how many stations are there, sir? 4 stations are there. So, you can write precipitation of P by normal annual precipitation of P can be taken as number of stations. How many, sir? P, Q, R and S. We have P, Q, R. Here we have 1 station already. So number of stations left are 3. So precipitation of Q plus precipitation of R plus precipitation of S upon normal annual precipitation of Q upon normal annual precipitation of R, normal annual precipitation of S. See, students, here what is the important point is, you have station, some people will do this mistake. We have already taken 1 station here. You cannot add 1 by 4 because in the formula also, if you required, you write m minus 1 instead of 1 by m, where m represents the number of stations. You have to write m minus n. Here there are 4 stations, but you are taking the average of 3 stations. So here what is the annual precipitation? See, if you talk about P, their normal annual precipitation is how much, sir? 780. Okay, is equal to 1 by 3 upon of Q is how much, sir? 850, 920, 980. So you can write 850 plus 920 and the last one is by 980. I am just writing the normal annual precipitation. Now, my dear students, what is the precipitations of Q and R? But remember, students, the station S was missing. What is the precipitation of P? See, here they have given, in the year 2013, the station Q and R were operative, but P was not, using the normal ratio. The precipitation of P for the year 2013 has been estimated as 860 mm. So here it is how much, sir? This is 860 mm. If the observed values of Q and R are how much, sir? 930 and 1010. But what is asking? What was the observed precipitation of station S? So here station S is missing. So you have to write precipitation of S. Now, my dear students, what is the formula here is, if you have some precipitation P of X comma N of X, where P of X represents the precipitations and N represents the normal annual precipitations, is equal to 1 upon M minus 1. Here, my dear students, what M indicates is, M indicates the number of stations. What is M indicates, sir? M indicates the number of stations into P1 of N1 plus P2 of N2 up to M stations. Up to M stations, you can write. Okay, so this is how we solve the problem. When you just plug in these values, what will the value of PS, sir? If you see, the value of PS here is 1093.43 mm. So this is the precipitation of station S. Now, my dear students, again let me tell you the key point in this. Whenever they have given you the missing station precipitation or missing normal annual precipitation, the formula related to the precipitation and the normal annual precipitation is P of X by N of X is equal to 1 upon M minus 1, where M indicates the number of stations and it is the summation. And remember, P indicates the precipitation and N1 indicates the normal annual precipitation. I hope this solution is clear for you. Students, if you are enjoying this session, please share this session to your friends. And let me tell you one important thing, students. we at IMS Gate Academy were very passionate to deliver the lectures in the perspective of the student in the last minute preparation. So we have come up with the Gate Score Booster where you can boost yourself. It is something like a capsule. If you are aware of the subject, the concepts and everything, then this is the right place because you can practice with the beautiful examples and you can go through the key pointers. And remember, my dear students, as I told you, the classroom notes, what we have discussed in this session, will be shared in the Telegram group. So, my dear students, if you are really interested to have the notes, then definitely you have to join the Telegram group to access these notes. Okay, let me go into the next question, my dear students. This question is a very interesting question, students. Now, what is the option here? A ISO height is a line joining off. Now, my dear students, I don't want to explain just the answer. Let me tell you, in GATE exam, we are coming with a question called multiple select question. So, let me tell you what happens with this. Now, if you see here, see students, he is asking what is a line joining. Sir, what is a line joining equal temperature? Now, my dear students, what is a line joining equal temperature, sir? A line joining equal temperature is nothing but we call it as isotherms. Line joining equal temperature is called as isotherms. Now, my dear students, a line joining equal humidity, we call it as isohum. Okay. And remember, my dear students, a line joining equal evaporation is known as isopluth. Is known as what, sir? Isopluth. Now, you can ask me, sir, what do you mean by line joining equal rainfall? This is nothing but iso height. So, if you can remember in this way, so in this question, we have 4 topics. A line joining equal temperature is known as isothermal. A line joining equal humidity is known as isohum. And a line joining equal rainfall is known as iso height. And a line joining equal evaporation is known as isopluth. So this is the important point where you can take forward if they ask you for any other line. So a line joining, iso it is a line joining points of equal rainfall. Isotherm is a line joining points of equal temperature. Isopluth is a line joining points of equal evapotranspiration. And you can write, equal evaporation. A line joining equal humidity is known as isohum. So in this way they can ask the question. Now please solve this question. I'll give you 2 minutes of time. Sir, I have given you enough time, see students. The question here is, see students, a 1 hour rainfall of 10 centimeter magnitude at a station has a return period of 50 years. Okay, and the probability at 1 hour 10 centimeter more will occur in each of the 2 successive years is. Now see students, let me tell you first of all, when I ask you this about this problem, you should know some basic students. What is the basic here is, there is a probability concept NCR into P power R into Q power R, Q power N minus R. It is the probability of occurring R times in N years. What sir? R represents the successive years, N represents the total years. So, what do you mean by P here is, P is nothing but the probability of success. So, the probability of success that is P is given by the formula. How do you get the probability of success? See students, P is nothing but given by the formula 1 upon T, where T indicates the return period. Where T indicates what sir? Return period. So here probability of success P is equal to 1 by 50. That is equal to how much sir? 0.02. Now how do you calculate the unsuccess? Means you know the probability of success plus not success should be equal to 1. So here Q will be equal to 1 minus P, that is equal to 0.98. Now he is asking 2 successive years and 2 years. Very good evening Rajkumar. Very good evening. So here if I apply the formula here in this and I have just plug in these values, you will get 2CR, 2C2 into 0.02 power R is square into 0.98 into 2 minus 2. So it will be 1. Anyhow, this value will be 1 and this value will be also 1. So you will get a value of 0.004. So the answer here is 0.004. So there is something related to hydrology irrigation is, how do you calculate the probability of success? The probability of success is nothing but 1 upon return period. If you can solve that point, that is the key point. Remaining thing is just apply the mathematics probability concept. The probability of success is given by the formula 1 upon return period. That will help you the success. Once you know the success, 1 minus the success is nothing but the unsuccessful. So using these values, I have just plug in these values in the formula and I got that. Sir, how many students apply in Gate 24 in Triple branch? Any idea? Good evening, Rajkumar. The question you can visit, actually I am not aware. We have Vipin sir and Nikhil sir in electrical, or JP sir we have. You can contact them. Okay, in the YouTube channel in IMS Gate Academy. I am from civil engineering background, but still JP sir or Nikhil sir or Vipin sir might help you to answer your question. And remember, if you want to have a shortcut answer for this, just visit the website of IISc Bangalore. But still, now that information will not be listed in that. After some time only they will be listing that. Okay sir, I hope I have answered your question Rajkumar. Still, if I have not answered your question, we have Vipin, Nikhil and JP in the Telegram group. In the description we have given that link. Join the Telegram group and you can ask Vipin or Nikhil or JP sir. They will have the right answer for you. Okay, thank you. Now see students, we have another question here. What is the another question here is, the probability that a 50-year flood may not occur at all during 25 years life of project is dash. Now see students, let me tell you one important thing. Whenever they ask you the term hydraulic risk or hydrological risk or not occurring, if they used the word risk, hydraulic risk or not occurring, both represents same sir. Okay, but see students, why I want to tell you is, when they ask you risk or not occurring, there is a difference here. Risk means if it occurs at least once. Let me tell you, if they ask you, I'll tell you how it is. Risk, 1 second, sorry students. If they ask you risk here, if they ask you hydraulic risk or hydrological risk, when they ask you the term hydrological risk, then you should be careful that risk is termed as like this. See here. Usually risk means at least once. If the risk means if it has occurred at least once, then failure will happen. So when they use it, it is out of this box question, students, but let me tell you, when they use the word hydrological risk, then you have to take the probability of occurring at least once. But here in this problem, they have given clearly the probability of not occurring. So here what is the return period, sir? See students, here if you see the return period, if you see the return period is given as how much, sir? 50 years. The return period is given as how much, sir? 50 years. So here what I would like to tell you, return period is given as 50 years. So the probability of not occurring is how much, sir? 1 by 50. That is equal to 0.02. Now my dear students, if you talk about the probability of not occurring, then it is called as 1 minus P. How do you calculate? The probability of not occurring is 1 minus P. Then it is equal to what, sir? 1 minus 0.02. So this value will be equal to how much, students? This value will be equal to 0.98. What is the value, sir? This will be equal to 0.98. And here the probability of not occurring for 25 years is given by the formula Q power n. So 0.98 power 25. If you solve this, you will get a value of 0.60. Okay, my dear students, I hope this solution is clear for you. Okay. Now this is another interesting question, sir. I'll give you 2 minutes of time. Okay, sir, I have given you enough time, students. I have given you enough time. Here, what is the question here is, what is an hydrograph? See, students, if you see hydrograph means where you can see the intensity and time, means you can identify the rainfall in a bar chart kind of stuff. So, the hydrograph of a duration is 140 minutes. Total duration is 0 to 140 minutes they have given. The infiltration capacity is given is 17 mm per hour, which linearly decreases. They have given the line here. As the event progresses, the infiltration rate attains a value of 4 mm per hour. Okay. So here at T is equal to 100. Okay. At T is equal to 100. Remains constant. The value of the infiltration index will be. So what you are asking, sir, is asking what is the value of phi index. So if you talk about the phi index value, students, let me tell you what is phi index is. It is nothing but precipitation during the time of excess minus runoff upon time of excess. This is the formula, sir. This is the formula for phi index. So what is the runoff they have given you? They have given you, see here, time is how much, sir? 100 minutes. Agree or not? Time they have given us 100 minutes. Now just see this problem, students. What they have given you here. Okay. Now, my dear students, how do we calculate precipitation? Now, precipitation, which are values are more than 4, 15, 10 and 8. Now, see students, they have given you W index as 4 mm per hour. The values which you take during precipitation of excess 4 mm, there are 3 values. What are those? See. So, precipitation of excess is equal to how much, sir? 15 plus 10 plus 8 mm. What are the values? They have given this value. Okay. Into, what is the value? 20 minutes. 20 minutes means 20 by 60. So, because 20 minutes, if you convert into hours, it will be 20 by 60. So, excess precipitation is 11 mm. So, what is the value, sir? You got 11 mm. Okay. Now, what is the runoff value? Sir, how do you calculate the runoff value is? See, students, this is very important thing. How do you calculate the runoff value is? You have to calculate these areas first. All these areas should be find out to get the value of runoff. So how do you calculate the runoff here? See, students, how do we calculate the runoff here is? Now see, students, this is 15, right? But here the value is how much? 5. So 15 minus 10 is how much, sir? 5. So it is a rectangle. So, but it is 20-minute duration. What is the duration, students? It is 20 minutes. It is 15 here, and here you have the value of 10. So you can write here runoff is equal to 5 into 20 by 60 plus, this is another, this is C, students. This is, you can write this as one triangle. See, this is one triangle. That is how much, sir? Here it is 8. This is 10. So how much, sir? 2. So half into base into height. Half into 2 into 20 by 60. We got this area. Now see, students, this is 10, this is 8. So 2 plus 2 into rectangle. 2 into 20 by 60 plus this entire triangle. What is this value? Here it is A and here it is 4. So 4 into half into 4 into duration is how much, sir? 60 to 100. It is 40 by 60. Are you getting, my dear students? Now let me tell you, whatever the area above the line will get to the runoff value. How do you calculate is? See, students, if I consider this as one rectangle, this is one area. This is the second triangle, that is 2. This is third one is rectangle again. And we have the another triangle, this is 4. So I have just plugged in these values. So 5, here you can solve this. If you see here, you will get a value of how much, sir? 5 plus. Okay, 5 plus, here it is 1. Here you will get how much, sir? 2. This is how much? 2. Yes or no, students? Is it 2, sir? 2 into 2. So here it is 4 you will get. 5 plus 2 plus here 2 into 2. It is 4 into 20 by 60. Okay. Now let me write here. 5 plus 1 plus 2 plus, here 2 2s are 20. 4 into 20 by 60. So here it is how much, sir? 5, 1, 2, 4. It will be 6, 7, 12. So the 12 divided by 1 by 3. This will be equal to 4. Are you getting me? 4 mm. So here what is the precipitation? 11 mm. What is runoff? 4. Time of excess how much, sir? Time of excess is how many we have? 1, 2, 3. So this will be equal to, I will write here, 11 minus 4 upon 20 by 60 plus 20 by 60 plus 20 by 60. We have time of excess in 3 cases. So this entire thing will be equal to 1 hour, and 11 minus 4 is 7. So this value will be equal to how much, sir? So this value will be equal to how much? 7 mm per hour. This value is equal to how much, students? This value is equal to 7 mm per hour. I hope this solution is clear. See, students, here what I would like to tell you here is, the most important thing is when I talk about phi index. Phi index is given by the formula precipitation of excess, means you will find out W index. In this problem, W index was given as 4 mm per hour. You have to take the values which are more than 4 only. There are only 3 cases, that is 5, 8 and 11. I think what, sir? We have done what? 15, 10 and 8. Okay, so there are 3 cases, and above line we will get the runoff upon time of excess. So there are 3 times, that is the reason 3 into 20 by 60 can be 1 hour, and runoff you get the area which you have calculated, rectangle, triangle and triple, like another triangle, and you got a value of 7 mm per hour. I hope this solution is clear for you. Okay. Now this is another interesting question, Amma. Just you have to solve this problem, students. I'll give you 2 minutes of time. Just go through the question. Okay, sir, I have given you enough time, students. Okay. So here, what is the question here is, the average surface area of a reservoir of a month of June is 20 kilometers square length. In the same month, the average rate of inflow is 10 meter cube per second. Outflow is 15 meter cube per second. Rainfall is 10 centimeter. Monthly seepage loss is 1.8 centimeter. And the storage is 16 million meter cube. What is the evaporation in that month? See, students, whenever they have asked you these kind of questions, the basic agenda is, we have one basic equation. Like law of conservation of mass also we can say, but this is the basic equation, sir. What is the basic equation is sum of inflow minus sum of outflow. sum of inflow minus sum of outflow. Sum of inflow minus sum of outflow is equal to delta S. What, sir? Sum of inflow minus sum of outflow is equal to what, sir? Delta S. So here what do you mean by delta S is? Delta S is nothing but what, students? It is nothing but storage. What is nothing? Delta S, sir? Delta S will be storage. What is delta S? Delta S is nothing but the storage. Okay. Now what is inflow? Inflow means which is trying to come. A rainfall can be an inflow. Now what can be the outflow? A seepage can be outflow. Okay, sir. And another important thing, evaporation can be also an outflow. So you have to be smart, students. What do you mean by inflow and what do you mean by outflow? Simple thing is, if you have a well, students, how the well can be filled, that is called inflow. How the well can be emptied, that is nothing but the outflow. Simple way how to remember whether it is an inflow or outflow. Inflow means which trying to fill it. So if your rainfall is there, the well will definitely fill. So it is an inflow. If there is a seepage, the water will be lost. So it is an outflow. If there is a heat or sun, the water tries to evaporate. That is also water is going out. So it is an outflow. So simple way to remember. Now my dear students, they have given you what, sir? The volume they have given as 16 million meter cube. And they have given you the area is how much, sir? 20 kilometer square. So my dear students, how to find out the storage depth? How to calculate the storage depth? So to find out the storage depth, my dear students, we have 16 million meter cube. So you can write it as 16 into 10 power 6 million meter cube. Okay, 16 into 10 power 6 million meter cube upon, this is what, sir? This is the storage. Okay, we are talking about what, sir? This is the entire volume upon area is how much, students? This is 20 into 10 power 6 meter. I am converting, sir. They have given 20 kilometer square. I am converting to meter. If you do this, you will get a value of 0.8 meter, or if you draw in centimeter, it will be taken as 80 centimeter. Agree? So one part we have done. What is the storage we got, my dear students? Storage we got a value of 80 centimeter. Now let me tell you, here they have given you the same month average rate of inflow is 10 meter cube per centimeter and rainfall is how much, sir? 10 centimeter. So if I talk about the inflow, okay, we have rainfall first, what, students? Rainfall is equal to 10 centimeter given in the problem. Okay, rainfall is equal to 10 centimeter. But inflow for the entire month, discharge is given as how much, sir? 10 meter cube per second. Sir, how to convert this into depth? Let me tell you. Sir, this is discharge. So if you multiply with the time, definitely it will be converted into volume. Divided by area, you will get, because the area is same. So here what you have to do, 10 meter cube can be taken as 10 into, sir, this is per second. Per 1 hour, how many seconds are there? 60 into 60. So 3600 per day into 24 hours. But they have given you the month of June. Okay, so for a month, you can assume there are 30 days. Divided by the area is 20 into 10 power 6. So this is the area, 20 kilometer square are given in the problem. So here 1 kilometer is nothing but 1000 meter. So you can take 20 into 10 power 6. On solving this, you will get a value of how much, sir? You will get a value of 1.296 meter. How much value you will get, sir? You will get a value of 1.296 meter. This is the value you will be getting in case of depth. So to convert this meter into centimeter, you can take it as 129.6 centimeter. So what is the inflow here? Inflow can be taken as 10 plus 129.6. That is equal to 139.6 centimeter. Agree, my dear students? Agree. So this is inflow. Still we are not done. Now, my dear students, what is the outflow, sir? Outflow is given as 1.8 seepage loss and 15 meter cube per second. What is the outflow, sir? They have given outflow. Seepage is how much, students? Seepage is taken as 1.8 centimeter. Okay. Now we have the outflow is how much, students? It is given as 15 meter cube per second. So in a month, same procedure, you will have 15 into, in a hour we have 60 into 60 seconds, into day is 24, into month is 30, divided by 20 into 10 power 6. So if you solve this, my dear students, you can simply take 129.6 into 1.5. But I am solving this. You will get a value of how much, sir? You will get a value of 194.4 centimeter. How much, sir? You will get a value of 194.4 centimeter. Or if it comes in meter, you will get 1.944 meter. You will get. If you convert into centimeter, you have to multiply with 100. Am I clear or not, my dear students? Now, see, students, you told me sum of inflow minus sum of outflow is equal to plus or minus storage. If the inflow is more, then storage will be positive. If the inflow is less, then the storage will be negative. So here, what is the inflow we got, sir? If you see the inflow here, 10 centimeter, and what we got? Sorry, here it is. Total inflow is how much, sir? 10 plus 129.6 centimeter minus outflow. What is the outflow we have? What is the outflow we got, sir? 194 and 1.8. 1.8 plus 194.4 centimeter minus of evaporation loss is equal to 80 centimeters. Okay, students, if you solve this, what you will get evaporation is also an outflow. You will get a value of 23.4 centimeter. So it is a negative value actually. So the answer here is 23.4 centimeter because outflow is more. So if you see the answer here, students, 23.4, option D is the correct answer. So my dear students, let me conclude this important question. We have one important relation. Sum of inflow minus sum of outflow can be plus or minus delta S, where delta S indicates the storage. If inflow is more, the storage will be positive. If the inflow is less, the storage will be negative. Now let me tell you another important thing, student. What I would like to tell you is rainfall and precipitation, all this comes under inflow. Outflow comes under seepage or evaporation loss, all will come under outflow. I hope this solution is clear for you. Thank you. Let me go into the next question. This is an important question, Amma. This is a GATE 2023 question. I want everyone to solve this question. I'll give you 2 minutes of time. Now see students, I have given you enough time, sir. Sir, a 12-hour storm occurs over a catchment in a direct runoff is how much, sir? 100 mm. Okay. The time distribution rainfall, the phi index of the storm. So first what I will do is, this is 100 mm, right students? So runoff is how much, sir? Runoff is given as 100 mm. Okay. Now how do you calculate precipitation, sir? Precipitation is nothing but the area of this diagram or area of the runoff diagram. So how do you calculate half into trapezoid? Half h into a plus b is the trapezoid formula. So here see students, we have half h into height is 20, 20 into 4 sir, this value is how much, sir? This is 4, this is 6. So 6 minus 4 is how much, sir? 2. So the top width is 2 and the bottom width is how much? It is 12. So this value, if you take this, you will get a value of 140 mm. So if they ask you what is infiltration means, infiltration is nothing but 140 minus 100, that is equal to 40 mm. Or you can write it as 4 centimeter. Okay. Now my dear students, what I would like to tell you here is, but is asking the phi index value. So for phi index value, what we have to do, this is the important problem. In gate 23 also they have asked you. So what we have to do is, we will draw one line here. Okay, we will assume that this length height is x1. Okay, and we will assume where it cuts. So here if you cut, here we will assume this as y1. Similarly, it cuts here, this we will assume it as x because it's a straight line. And we assume this as y2. And what will be this height, sir? This length will be 12 minus y1 plus y2. Are you getting me, students? So see here, what it's a simple thing, sir. We have a diagram here, okay. One second. See here, students, what happened here is, we have a diagram here, which shows in this way, right? Here we have a value of 20. Okay. Now see students, I will assume somewhere here the x value, which should be the phi index value. This is x. So here this value will be taken as y1. Okay. Here this value will be taken as y2. But here to here the total value is 12. So this distance, whatever you are having here is 12 minus y1 plus y2. So first of all, what you have to do is this area, whatever this area you are having, right? Shaded portion, which I am having. This area you have to calculate. First of all, see students, this is one triangle, this is one rectangle, and this is another triangle we have, right? So here, how do you interpolate this? Now see students, x by y1 can be taken as, this is 4, okay, x, and this is 20. So you can write it as 20 by 4, right? So x is this one, this is 20. y1 is this one. So here we have this value as 4. So y1 can be written as what, sir? X by 5. Similarly here, see student, x by y2 can be written as what, sir? X by y2 is how much you can write? 20 divided by, what is this value, sir? From here to here it is, this is 6, right? So this is 6, right? See, from here to here 12 minus 6, so it is 6. So y2 is equal to how much, sir? y2 is equal to, how much this one? 5 by 3, right? So y2 is equal to 3x by 5. Yes or no, students? Am I correct or wrong? So x by y, okay? You got y1 and y2. Now what you have to do here is, how do you find the area of the shaded diagram? Shaded diagram is half into x into y1 plus, what is the area of rectangle? 12 minus y1 plus y2 into x plus half into x into y2. Okay. You have to calculate all these areas, sir, and equate to 0. Now, if you solve this, you will get a value of x is equal to 3.6 mm per hour. And remember, you will have other value also, which is 44. But this will be the value because it cannot be more than 40. So the answer here is 3.66 mm per hour. I hope this procedure is clear for you. Thank you. Now we'll move on to the next question, sir. Please see this question. I'll give you 2 minutes of time. I'll give you 2 minutes of time, students. Please solve this. Okay, students, I have given you enough time. The question here is, please read the question. In a Horton's equation fitted to the infiltration for a soil, the initial infiltration capacity is 10 mm per hour. Final infiltration capacity is 5. And the decaying constant is 0.5 per hour. Assume that infiltration takes place at rates. The total infiltration from a uniform storm of duration 12 hour is. Now see, students, what here I would like to tell you is, infiltration at a time t is given by the formula final constant infiltration plus initial minus final constant infiltration into e power minus k into t. This is the actual equation. How this equation came is, we have a parabola here which indicates, this one indicates the f of f naught, which is initial infiltration, and here we have the f naught. What is this, sir? F naught, this is the final, or you can say this is the infiltration initial, and here we have not, this is the final infiltration, right, FC. So from this we got this equation. Now in this problem C, students, what they have given is, initial infiltration is given as 10, final is given as 5. So if I plug in these values, f of t can be written as 5 plus 10 minus 5 is 5 into e power minus 0.5 into t. Okay. Now we have to apply 12-hour duration. So you can write 0 to 12 f of t dt, which will be equal to 0 to 12 5 plus 5 into e power minus 0.5 into dt. This is dt. Now what will happen here is, this will become as 5t, which will be equal to 12 to 0 plus 5 into e power minus 0.5 upon minus 0.5 into, because integral e power x is e power ax by e can be written as e power ax upon a. So we got it as 12 to 0. If you substitute the values 12 and 0 in this equation, you will get a value of roughly around 69.975 mm, which you can take it approximately as 70 mm. So in GATE 2023 also they have asked this kind of question, students. So remember this equation. It is a decaying one where F0 indicates the initial infiltration, Fc is the final constant infiltration rate, and here K indicates decaying constant. In the problem, if decaying constant will be taken as per hour, and it in the problem they have given clearly it as 0.5 per hour. So this is how the generalized equation. So what is the key point I would like to tell you is you have to remember this generalized equation and just integrate if the number of hours are given. By using this question can be answered very easily. I hope this solution is clear for you. Now please solve this problem. This is a very interesting problem, student. అన్నాను కదా నీకు నిల్చోనేది స్ట్రెయిన్ అవ్వద్దు, నేను వచ్చే వరకు వదిలి లేకపోతే వండకపోతే ఆ కుర్చీ వేసుకొని కూర్చో, అర్థమవుతుందా? నేను అదే టెన్షన్ పడుతున్నాను. ఓకే ఓకే నేను ఒక గంటలో వచ్చేస్తాను. Okay. See students, whenever this kind of question is asked, the question here is the hydrograph in the figure corresponds to a rainfall intensity of 3 centimeters. If the rainfall intensity has produced a direct runoff of 1.6 centimeter, the phi index of the storm in centimeter per hour is. Now what I would like to tell you here is, first we will find out W index. How to find out W index is nothing but it is P minus R upon T. So here what is the precipitation they have given? 3 centimeter. So you can write it as 3 minus rainfall. Runoff is given as how much, sir? 1.6. See here it was given 1.6. 3 minus 1.6 divided by, what is the number of hours here? They have given 3.5 divided by 3.5. So if you solve this, you will get a value of 1.4 divided by 3.5. Okay, this is 2 by 5. So if you do this, you will get 0.4 centimeter per hour, or you will get 4 mm per hour. But now what he has asked in the students, he has asked phi index. So when you talk about 4 mm per hour, in phi index you have to take the values which are more than 4 mm per hour only. But if you see there is 3 here and another thing 4 which are not more than this. Now what is phi index here, I will tell you. Phi index is nothing but PE minus R upon time of excess. Are you getting, my dear students? So here the phi index is equal to PE minus R upon TE. So what is the total precipitation we have? Total precipitation is 3 centimeter, or you can write it as 30, right? Yes or no, students? 3 centimeter means 30 mm. And here you have how much, sir? 1.6 centimeter. Now how do you calculate precipitation of excess minus R upon time of excess? Just solve that. Okay, see student. Here when I talk about the precipitation of the success, here precipitation of excess minus R upon time of excess. See here, when I talk here, 12 is more, 15, 14, 4.5, 7.5. 3 and 4 are only there, sir. And here what is the duration? Duration is how much, students? The duration is how much? Half an hour. So we have two values, 4 into 3. Okay, now let me tell you. Phi index is equal to what, sir? Phi index is equal to precipitation of excess minus R upon time of excess. Okay. See, we have two values. One is what, sir? 4 and 3. And these are for half an hour duration. So total precipitation is how much, sir? PE is equal to total precipitation is 30 mm, 3 centimeter minus these values you have to remove. 4 plus 3 for a duration of 0.5. So this you will get a value of 26.5 mm. How much you will get, sir? 26.5 mm. So here precipitation of excess is how much, sir? 26.5 mm minus runoff is how much? 1.6 centimeter. I have taken as 16 mm upon time of excess. What is the time of excess? We have total time is 3.5. In that there are two durations which you have to remove. So it will be 3.5 minus 0.5 plus 0.5. So whenever I have solved this problem, see student, here you will get a value of 10.5 minus upon, this is 3.5 minus 1, it is 2.5. You will get a value of 4.2 mm per hour. So the phi index value here is 4.2 mm per hour. I hope this solution is clear for you. Okay, I'll quickly move on to the next solution. Now please solve this problem, students. Students, I hope you are following the concepts. If you have any doubts, you can comment in the chat box, students. Now see students, I hope you are clear with this. A canal supplies water to an average width over an area of how much, sir? Area is how much? Area is nothing but 100 hectares. What is the area, sir? Here we have area is nothing but 100 hectares. Okay, the duration between the first and the last crop is how much, sir? 120 days. Okay, and the depth is how much? 35 centimeter overall. But initially there is a period of 30 days. So my dear students, whenever they have asked you these questions, we have duty is equal to 8.64 into base period upon delta, where delta should be considered in meter. Here my dear students, if you take here 8.64 into base period is how much, sir? Base period is 30 days and depth is 12 centimeter. So 30 divided by 12 centimeter means 0.12. Okay, so it will be how much, sir? 2.5. Okay, 2.5 means 20. 250 I think. 250 into 8.64. What is the value you will get? You will get a value of delta is equal to how much, sir? 2160 hectare per cubic. How much you will get, sir? 2160 hectare per cubic. Am I clear, students? In the next case, what is the base period they have given? For the other case, what is the base period they have given, sir? We have total is 120 days, right? So in the next case, if you find out the duty for the next case, so out of 120, 30 days are there. Remaining days is how much, sir? 8.64 into 90 days upon. Delta is how much? Total depth is how much? 35 centimeter. You have already 0. Here divided by 0.23. So if you solve this, what is the duty value you will get, students? Here if you solve this, you will get a duty value how much? You will get a value of 3380.87 hectare per cubic. So we have two values. One is 3380.87. Other one we have is 2160 hectare per cubic. Now you have the area is how much, sir? Q is equal to area by depth. Area by duty. Area is how much, sir? 100 hectares, right? One value we got has 100. 100 divided by 2160. What is the value you will get, sir? 100 divided by 2160. What is the value you will get? You will get a value of 0.0463. What is the value, sir? You will get a value of 0.0463. Other value will be 100 divided by, what is the delta you got, duty you got? 3380.67. This will be anyhow lesser value than this. So the answer here can be 0.0463 meter cube per second. So this is how. Usually we have to take the highest value in this case. So the answer here is 0.0463 meter cube per second. Now please solve this question, students. I'll give you another 2 minutes. Sir, I am expecting this kind of question this year, sir. Either infiltration, this question. Now see students, here this is an important question, sir. A culvert is designed for a flood frequency of 100 years and was useful for 20 years. The risk involved in the design. Sir, that's what I told you. See students, whenever the word come risk, you have to remember if it occurs at least once, then obviously there will be a risk involved. It should not happen. If it occurs at least once, then also the risk will be involved. So remember, the probability of occurring at least once will be the answer for risk involved, sir. Are you following, students? The probability of occurring at least once will be the risk involved. So here if you see, what is the culvert, sir? It is designed for a flood frequency. So return period T is equal to how much, sir? 100 years. Return period T is equal to 100 years. So the probability of success is given as how much, sir? What is the probability of success here? They have given as 1 by 100, which will be equal to 0.01. Okay. The probability of not unsuccessful is nothing but 1 minus 0.01. So this will be equal to 0.99. Okay. Now what he is asking, the probability of occurring at least once. So the probability of occurring at least once can be written as 1 minus q power n, because they have given n as 20 years. So 1 minus 0.99 into 20 power 20, you will get a value of 0.1820, which is equal to, in percentage they have asked you, so this will be equal to 18.2 percentile. I hope this solution is clear for you. Okay, are you following, students? So whenever they've asked you whatever the probability of occurring at least once, the other way of asking is what is the hydrological risk, they can ask you. So here what is the risk involved in the design? It can be any structure, sir. They can ask you the word risk. So here what is the probability of success is P is 1 upon return period. Q is equal to 1 minus P. The probability of occurring at least once is taken as probability of occurring at least once is given by the formula 1 minus q power n, and using these three formulas we can solve this problem. I hope this solution is clear for you. Now please solve this question, sir. Now see students, I have given you enough time. What is the question here is the infiltration capacity of a soil is F is equal to what, sir? C1 plus C2 e power minus KT. Okay, the infiltration was initial was 200, final the infiltration capacity was reduced to 25 mm. That is final constant. And what is the infiltration? 1 hour is 90 mm per hour. Okay. Now see students, as I told you here, the infiltration at a time t is given by the formula initial plus F naught minus Fc into e power minus kt. This is the one. So here they have given you infiltration at a time t is 1 hour. They have given as 90. What is the value, sir? 90 mm per hour. So here what is Ft? 90 mm per hour per 1 hour. Initial was 200 plus F naught minus Fc is how much, sir? 200 minus 25 e power minus k into duration is 1 hour. Okay, now my dear students, see here. You can write 90 is equal to 200 plus 175 into e power minus k into 1. So if you solve this equation, okay, now see students, as I told you, remember always, in this case, initial infiltration, because it's a decaying constant, it is a decreasing curve, initial infiltration will be more, and the final, after it reaches a constant value, it will be constant. So that is very important, sir. So if you solve this, you will get a decaying constant value as 0.99 per hour. I hope this solution is clear for you. And again I am telling you, this Horton's equation is very important when you are solving the gate questions. Solve this question, students. Now see students, I have given you enough time here. Now what he is asking in the question is, a 12-hour unit hydrograph of excess 1 centimeter excess rainfall is in triangular shape, 144 hour, discharge is 23 meter cube per second. Now see students, see, area of the hydrograph will give you the runoff volume. Will give you what, sir? Here area of the hydrograph will give you the runoff volume. So how do you calculate runoff volume? Here we'll see. So my dear students, here we have the discharge. See students, if suppose this is a triangular in shape, is telling, and here the total discharge peak is 23 meter cube per second. So if I draw the graph between discharge and time, this is 23 meter cube per second. And here the total duration is how much, sir? 144 hour. So if you find out the area, how do you calculate? Half into base into height. So runoff volume is equal to half base is 144 hours. If you convert into seconds, 144 into 60 into 60. This is minutes and this is second. Into 23 meter cube per second. So this is the runoff volume. Okay. Now you calculate the runoff volume, but depth. Depth is given as unit hydrograph, student. Depth is given as how much, sir? Unit hydrograph. Depth is given as what, sir? Unit hydrograph. So here when they talk about unit hydrograph indicates what, sir? It indicates 1 centimeter. Unit hydrograph indicates what, sir? 1 centimeter. So if I take here, area is equal to half into 144 into 60 into 60 into 23 meter cube per second divided by, this is centimeter, student. So 1 into 10 power minus 2. If you solve this, you will get a value of 596 into 10 power 6. Okay, you will get a value of how much, sir? 596 into 10 power 6. So you will get this meter square. So you can write the answer catchment area as 596 kilometer square. Sir, this is as simple as this. See, students, usually what we have done is volume can be written as area into depth. Okay, if you want the catchment area, volume by depth is nothing but the catchment area. I hope this solution is clear for you. Okay. Please solve same kind of question, sir. I have given you another kind of question. Please solve this question. పంపుతున్నాను చూడు. Sir, see, the same concept what we have applied this. A triangular direct runoff due to a storm has a time base of 90 hours. The peak coordinate is how much, sir? 60 meter cube per second. See, students, if you see, this is a triangular thing. This is having peak value is how much, sir? 60 meter cube per second. Okay, it has a duration of how much, sir? It has a duration of 90 hours. So I told you the area of the hydrograph will be equal to what, sir? Runoff volume. So here see, students, runoff volume is equal to what, sir? Here runoff volume is equal to how, students? This will be equal to half into 60 meter cube per second. 60 into 90 hours. 60 into 90 into 1 hour is 60 minutes and 60 seconds. This is the runoff volume. Divided by catchment, they are asking catchment area is also given, sir. So as I told you, see, students, as I told you here, volume is equal to what, sir? Volume is nothing but area into depth. Okay. So area is given also has, now they are asking what, sir? Depth. So whenever these kind of questions are asked, see, students, here depth will be equal to what? Depth will be equal to what, my dear students? Depth will be equal to volume upon area. So remember, my dear students, what do you mean by volume, sir? The area of the hydrograph is nothing but the volume. So here volume we got value as how much, sir? Half into 60 into 90 into 60 into 60 upon area is how much, sir? 300 kilometer square. You can write it as 300 into 10 power 6, which is equal to 0.0324 meter, or you can write it as 3.24 centimeters. Just go through this problem, students. Next, please see these questions, students. Please observe this question, student. I'll give you 2 minutes of time. Please go through this question, student. Okay, sir, I have given you enough time, Amma. Here the question here is simple, sir. There is a reservoir 1 and reservoir 2. What is the difference in it, sir? Sir, see the question. Two reservoirs are connected through a homogeneous isotropic. K is equal to, K means coefficient of permeability, or you can say hydraulic conductivity, or 25 meter per day. Now to find out the velocity, students, we know according to Darcy's law, velocity is always taken as hydraulic gradient into coefficient of permeability. Here if you, this is 30 meter, this is almost 10 meter. What is the difference in head? I is nothing but loss of head per unit length. What, sir? Hydraulic gradient is defined as loss of head per unit length. So here you can write it as 30 minus 10 meter upon length is how much, sir? 2 kilometer. 2 kilometer is how much it is? 2000 meter. So this will be equal to 1 by 100, or you can write as 0.01. Now if you consider velocity, velocity is taken as what? 0.01 hydraulic gradient into 25 meter. It will be 0.25 meter per day. That will be the velocity. But here what we have to do? We have to calculate porosity is given. So seepage velocity can be written as velocity upon porosity. That is 0.25 divided by 0.3. Okay, sir. If you talk about this, seepage velocity is given as 0.833 meter per day. Okay, my dear students. Now, see students, here you should be able to understand that seepage velocity. Velocity is nothing but what's the distance by time. Okay, time can be taken as what? Distance upon seepage velocity. Distance is how much? 2 kilometers. So 2000 meter upon seepage velocity, how much you got? You got the value as 0.833 meter per day. On solving this value, you will get a value of 2400 days. Okay. Just go through this solution, students. Okay, students, I hope this session will be helpful for you. And once again, Happy New Year to everyone in advance. And the next year it will bring glory for you. And try to focus on whatever you want to do. And try to get, I wish you all the best for your success. And I wish you all the best for your future endeavors also. And see students, every time when you are preparing for any preparation, you should be focused. You should be self-motivated. These are the some things which you required very much, sir. Okay, these are the important things I would like to tell you, very important things. So, whenever see students, whatever you want the updates, what we do in that YouTube channel, please visit our Telegram channel. which is mentioned in the YouTube link mentioned below. And here you can the updates related to the quizzes or anything related to what's happening in the channel, like tomorrow what are the lectures we are trying to post and what are the questions. Like quiz questions are very important for yourself to grow. Like when you are near to the exam, you have to practice as many questions as you can. So you will have all the suppose now you want to access the classroom notes which is mentioned today's class, then definitely you should join this Telegram link. And one more important thing, students, I would like to tell you very important thing. We at IMS Gate Academy, Anay Tiwari, guys, I have a doubt. Tell me, sir. Tell me, Tiwari, what is your doubt? Guys, I have a doubt. Tiwari, you can post the doubt. Sir, we are the only institute in, means we are of, yeah. Sir, see, what I would like to tell you is we are offering 800 plus hours of gate coaching offline and online. Tiwari, you can post in the chat, okay? We are offering 800 plus hours of offline gate coaching in Bangalore and at Vijayawada also. We are providing the subject-wise material which contains both the subject-wise material which includes, okay, thank you. See, what we are trying to do is we are providing the subject-wise material and also we are trying to provide the exercise book questions which contains level 1, level 2, level 3. And the most important thing, sir, for wherever you want to have a practice, we are prepared. We have almost delivering 130 plus tests, which includes subject-wise tests, advanced level test, multiple subject test, chapter-wise test, and all India mock test series. And the key success for student is one-to-one mentorship, where the sir, you teach very bad. Which question? Okay, thank you. Okay, thank you, Tewari. Okay. Thank you. I'll try to. Okay, thank you for your information. Okay, next what I would like to tell you here is we are offering 12 My Plan sessions, one-to-one mentorship. And if you talk about the 130 plus online test series are also provided, sir, where it has video solutions and all. Okay. And another important thing I would like to tell you, students, if you are really want to have a experience of the offline gate coaching center, then definitely you should visit our center. Thank you.